All right, boys and girls, get excited because Mr. Jordan is back to tell you all about sections 5.4 and 5.5, properties and conditions of rhombuses, rectangles, and squares. Now, all of these figures are also parallelograms, so all of those properties that Mr. Fagan talked to you about parallelograms, all of those same things also hold true for these figures. But let's talk specifically about these. So first off, we have a rhombus. Well, a rhombus is a parallelogram with four congruent sides. A rectangle is a parallelogram with four right angles. All right. And lastly, a square is a parallelogram with four congruent sides and four right angles. All right, now we have some special properties of these figures here. So first one is a rhombus. So this theorem 16 or 6-13 tells us if a parallelogram is a rhombus, so I'm saying it's a rhombus, then its diagonals are perpendicular. All right. Also, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. All right, so diagonals perpendicular. Remember, perpendicular means they form a 90-degree angle there. And diagonals bisect a pair of opposite angles means bisect, remember, means it cuts an angle exactly in half. All right, so that's kind of the 5.4 section of this. The 5.5 section of this is where these kind of go in the opposite direction. And you saw that also in 5.2 and 5.3 there. So also, if I have a parallelogram whose diagonals are perpendicular, then that parallelogram is a rhombus. Also, if I have a parallelogram where the diagonal bisects a pair of opposite angles, okay, it only has to be one diagonal bisecting those pair of opposite angles, then it's a rhombus, okay? So we get that there in both directions. All right, so let's take a look at this example here. Let's use these special properties of rhombuses, see if we can answer this. So what are the measures of the numbered angles in this rhombus here? So we want 1, 2, 3, and 4. All right, well, we're given the one angle there is 58. If we use the second theorem there, diagonals bisect a pair of opposite angles, right? Well, first off, we will know that this one here is also 58 degrees here, okay? We also know that diagonals are perpendicular, so that means this middle angle is a right angle, and all those middle angles are right angles, so they're all 90 degrees. Well, if the middle angle is 90, this angle here, and let me actually do this so we can see what I'm talking. So this angle here is 90, this angle here is 58. I can find this angle down here because all of those angles have to add up to 180 degrees inside a triangle, okay? So I'll do my 180 minus my 90 minus my 58, and that gets me an angle measure of 32 degrees down there, right? Well, if this diagonal here is bisecting also, if that's 32, that must mean that angle 4 is 32. So the measure of angle 4 is 32 degrees. All right, angle 1, since they're perpendicular, the measure of angle 1 is going to be 90 degrees. All right, now again, for angle 3, I can use this fact. I have a 90, I have a 32. Subtract those from 180 and get what the measure of that angle is. Well, coincidentally, it's what's across from it there. So measure of angle 3 is going to be 58 degrees. And again, if that diagonal from B to D bisects angle D there, then if angle 3 is 58, the measure of angle 2 is also 58 degrees. Okay, so we're using our properties of rhombuses to get those angle measures there. All right, now the special property of a rectangle. So if a parallelogram is a rectangle, then its diagonals are congruent, or the same length, right? Similarly, so that's 5-4. 5-5 says that if I have a parallelogram and its diagonals are congruent, then we can say that it's a rectangle. All right, and on the square side of things, we get both of these. So if we have all of these things true, then it is a square. So diagonals are congruent, and our information from our second slide there, so diagonals bisect the opposite angles, and the where they intersect is a right angle there, then we also get that it's a square. Okay? So let's see if we can use this information here for solving this problem. So if ln, so L to n, so this diagonal here, is 4x minus 17, and m to o, so this diagonal here, 2x plus 13, what are the lengths of the diagonals of this rectangle? Well, it tells us here that the diagonals are congruent, so I can take 4x minus 17 and set it equal to 2x plus 13, since these are the diagonals. Congruent means equal, and I just got to solve this equation. Add 17 to both sides, we get 4x equals 2x plus 30. Subtract 2x from both sides, we get 2x equals 30, so x is equal to 15. Now, that's not what the length of both of them are. I need to substitute that back in. If I substitute that in for ln, we'll do 4 times 15, which is 60, and 60 minus our 17 there is going to give us a length of 43. Now, I could plug this in also for my second one there to find out what MO is, but we already know that if it's a parallelogram, then the diagonals are congruent, and if ln is 43, then MO also has to be 43. Okay? All right, now this part here is like our section 5.5 piece where we're seeing, can I use those properties then to make the claim that these are one of those special parallelograms, a rhombus, a rectangle, or a square? So this first one here, can you conclude that the parallelogram is a rhombus, a rectangle, or a square? Well, what I'm shown in the picture, okay, so I'm told it's a parallelogram, and now I see I have this diagonal, and those little marks tell me that the diagonal is cutting those opposite angles in half, or bisecting those opposite angles in half. Well, that was one of my properties there. It told me if it was a rhombus, that the diagonals bisected the opposite angles. Well, since this diagonal bisects the opposite angles, I can say that this is a rhombus. Okay, now on my second one here, can you conclude that the parallelogram is a rhombus, a rectangle, or a square? All right, so let's take a look here. Well, we have diagonals that are perpendicular. We have that little right angle symbol in the middle there. So if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. All right, so we know that this is at least a rhombus. All right, now we also have that those diagonals there, okay, if we see those little tick marks, all right, that's telling us that each of those lengths are the same. Well, if each of those lengths are the same, then the diagonals themselves are the same, right? You know, we say each one's 4. Well, if each one's 4, 4 plus 4 is 8, and 4 plus 4 is 8. So they're all going to be the same. So the diagonals there are also congruent. So that makes it a rectangle. Well, if something is a rhombus and a rectangle, if it has both of those properties, then we say that that is a square. All All right, the final type of problem we're going to look at here is, again, just kind of solving problems to see what might need to happen for it to be these types of figures here. So taking these special properties into account, wants to know for what values of x is this figure, A, B, C, D, going to be a rhombus? Okay. Well, again, if it is a rhombus, the diagonals bisect the angle. So if it bisects, that means these two angles at B, so ABD and CBD, they have to be congruent or equal. So I can take these two expressions, 6x minus 2, and set it equal to 4x plus 8, and then we're going to solve. All right, so we'll add 2 to both sides. 6x equals 4x plus 10. Subtract 4x. 2x equals 10. Divide by 2. So the value of x that would make this a rhombus is 5, because 5 is the value that would make both of these angles equal here. All right, on this next one, for what value of y is this going to be a rectangle? Again, we're going to want to set those equal to each other there, because if it is a rectangle, the diagonals have to be congruent. All right, for the diagonals to be congruent, those two segments are going to have to be equal there. So we'll let you guys go ahead and set that one up and solve for that one there. So there's 5-4 and 5-5. Hopefully you took some notes, and hopefully you got some good information out of this. If you need to review anything, feel free to go back. Remember, you can always pause the video at any point that you want to and check what you are doing there.